All right, hi, this is Will, and now we're going to finish up on our code here. And I noticed this last thing I put in here. So we have this reset going to reset this counter, but the resets a bunch of other things that we have. And we don't want to just, we want to keep this counter value. We do want some mechanism to reset it. So what we are going to do is I'm going to put another timer down here. And I think this would be timer T3. Let's see, yeah, T3. So I'm going to make this my, let's see, okay, I'll make it T3. And what I'll do is I'll make the set point 5 seconds. So we aren't going to reset that counter unless I actually have my finger on that push button for 5 seconds. So what I'm going to do is I'm going to go down here and I'm going to put my reset down here. And I'm going to make this X003. And so now when I do that and I'm enabling my timer, I have to hold it down. Normally when I press the reset, I just press it and release. But to reset this, I'm going to have to press it and hold it for 5 continuous seconds. And then this is going to become my T3. And I need to give that a name. So I'll call my T3, it'll be my counter reset. So this guy is counter reset. Okay, so I think that's all I wanted to do. So now what we're going to do is we're going to add lights. And the only one we said we were going to do is, we said that when we had a system fault, we were going to blink the red lamp on our actual stack light. Now, I think what we would do is for the green up, we're going to have it, well, green is up, yellow is down. Now, I was looking, and we have one final thing, is we said that if we're going up and we hit the down button, we want it to stop. And so that is kind of, and we'll make that blink yellow too, but that is, we need a signal that tells us when we're stopped, neither in the up position or the down position. So how's that going to work? So we don't want it on if any of our drives are running. So if we're going up, it's going to be off, and if we're going down, it's going to be off. So while the motors are going up, or they're going down, so they're going to be normally closed, and we don't want to be at either of our limits. So we don't want to be at the switch up or the switch down limits. And I think we said that those were C6 and C9. Okay, so we're not at the open switch limit, and we don't want to be at the closed switch limit, which was C9. So C9, and we call this output signal, and let's see, give us a, so our next C bit is going to be that, C17, and we should give it a name, and I guess the door in no man's land, but let's call it door, let's call it door ajar. It's not a door, it's a jar. Okay, so that's what we need. So now what we're going to do is we're going to have a blinking circuit. It's going to blink for both yellow and red, depending on what we're doing. So we're going to have our standard timer circuit. So we'll go down here, we'll put in one timer, and now if we just put in T3, this is going to be T4, and we're going to have this blink at half-second rate. And so we're in milliseconds, and we're okay there. Now we're going to put in another timer right below it, and this will be T5. And again, it's going to blink, so one will just feed into the other one. T5, T5. And again, we'll make this half second. Now, you know, when you set these up, these don't have to be, this one's a half second, this one does not have to be a half second. I mean, you can have it out for half a second and then on for a full second if you want. Just to be clear on that. So we're going to have a normally open contact. We're going to make sure that our system is on. That's C1, and we have to make sure that we have a fault. So I can't remember what the system fault is, but we had a bit called system fault. Okay, there it is, and it's C14. So when we have a system fault, we're going to blink the light, and we are going to have this one run for a half second, and then when this one times out, so this will be normally open, we'll give that T4, and then this one will count for a half second. And again, like in all of our blink timers, we're going to have a recycle timer, and I don't want to put it there. I want to cancel that. I want to put it here on its own line. So one will be T4, and the other will be T5. And this will be our blinking mechanism. When they're both high, that'll be the recycle timer. So that is going to be, I think C18 is where we said we were. Okay. And we're okay with that, and we'll call this recycle timers. All right, and all we have to do is into our initial timer. So these will be high when this one, this will be high, and when this one goes high, we want this low. So this is a normally closed contact, and this will be C18. Okay, so now what are we going to do? So now I'm going to take 3 more rungs, and I'm going to make these our outputs. And our outputs are still, as always, line 001 is red, and 002 will be our yellow, and 003 is going to be our green. And I guess I'll start out with the green. That's the easiest one. So I'm going to say when I am in my start process, C1, and my drive is going up. So that'll be normally open contact, and that'll be Y004. It's going to be green. Now I can use the same construction here for my yellow lamp. So this will be when I'm in start process, C1, and now my motor has gone down. Okay, now that's going to be, that's Y005. Now that's going to be a solid yellow lamp. Now I also need to, in parallel, so I want a branch circuit, I add a row, and so when this is high is when I want, when this one is counted out, I'm going to turn this on. So it's going to have T4 in there. So we have start process in there, so it's not going to count unless we're already in start process. So I can probably say the yellow lamp is going to blink, so it's going to be T4. And it's going to be when the door is ajar. So I'm going to put that in there as a normally open contact, and I think that was C17. Take a look here. Yeah, C17. Oh, so that was in the wrong place again. I want to put this here, make this a normally open contact, and this will be C17. Okay, and I'm just going to line that up. So edit, line it up. So now my red, do the easy one is when we're normally closed and not in start process, so that's C1. And again, we'll just insert a row beneath it. Now this one is going to be just like this. So it'll be when T4 is high, and instead of door ajar, it'll be when we have the system fault. So it's normally open contact to be T4. And let's see, where's our system fault at C14? So another contact C14. So red will be blinking when it, and I got this T4 here in a couple places. I need to put a name there. So when T4 is on, the light will be on. So I'll just call this blink on. So when it counts out and T4 is high, which that's T4, then we'll have the yellow light or the red light on. And I need to line this up. So I'll go over here and I'll put that there. And let's want to do it. So, okay, there it is. And the last thing I've got to do in all our programs, the last line is going to be your end statement. So, I think from taking a look at what we did before, you should be good. So, again, just to recap, we're going to use these triggers to trigger everything. When we get the open pulse that says the open door, and the motor's not going down, we're going to go up, and we'll go up until we get the open limit switch, and this will be going through a trigger pulse. And the only thing that can stop us, either up or down, they're the same thing, only, they're the same thing, is this stop door pulse. And that's going to stop it when we're going the other direction. We have this circuit that's going to time up and time down. And we have this one where we can inject a fault. And we're okay with that. So, this is if we have a fault bit here, we're going to stop the count, so we will see a fault. Here's a 15-second timer that's going to simulate a fault. And here's our system fault. T2 will be, let's give that a name. And we'll call that a door alarm. And it's an alarm because there's something trapped underneath the door when we're trying to do this. And we have the system fault. Here's, when we count up to 120, we get an open limit. And these are things we are generating in our simulation. And the closed door switch. And we have the fault inject where we're going to stop the counter when it hits 50. We have this door cycle, which I still don't like, but that's in there. And now we put in this reset, and the reset is, again, when we're going to have to hold it down for 5 seconds, and then we get this counter reset pulse. And we have the door ajar, so it's when none of these conditions are true, and then we just have our blink timer. So let's kind of download this and see what's going to happen. And I think I need to turn on my PLC. And we try this again. So it was in the power is off to it. So now let me connect it. And we're okay to connect. I have said I'm going to do this with the serial interface, and I will do that once we start getting into the wonderware. It just is, I don't know, I still think it's more convenient to program with the Ethernet. We're going to connect up. We are not going to write loose in there. And not sure what happened here. Let's see, we want to write this project into here. Okay. And the transfer is complete. We're going to put it into run mode. Now, just to make sure that we have no timers, timing, and whatnot, I'm going to hit reset. And, okay, we're setting with nothing happening. Now, I am going, up here, this top switch is to say I'm going up. This one is to say I'm going down. This one is to inject the fault. Now, I want to put these all, the off position is here, and then the active position, I don't know if you can see that, it says on is over here. So, and these are toggle switches, so they're not push buttons. But when I want it to go up, I'm going to flip it over to the left. And when it's done, I can flip it back to its normal position. So we're going to start, we hit reset, and I don't think we're in start process yet. So I'm going to go into start process. Our red lamp will go out. Now right now, nothing is going to turn on the way we have it configured. So there are no lights. Now as soon as I flip this switch, the top one, we should be counting up. On our counter, the motor up should go up, and if I can move it just a little bit. So what we want to see is I hit that open pulse. It's going to turn this on. It's going to start this counting, and we can watch it count. Now this is the thing that's counting 10 times a second. And this will stay on until we get our open limit pulse. And that's what we generate from the comparator circuit. So let's take a look. Oop, wrong switch. Okay, so now we're in the up mode, and you can see we're counting up here, and we're going to count up to 120. And again, this is counting up in seconds. This is kind of counting up 10 times a second. So when it gets to 120, it stops. And our lights go out. Now, and I'll just keep it here. So now I'm going to hit motor down, and we're going to start counting down. So count up, this circuit is active. When we count down, this circuit is active. And they're the same except for this fault inject bit, which we do in down only. So we're going to switch this back, nothing happens, because it's only looking for the positive edge. So now I'm going to switch the door down, and now the door is going down with the yellow, and it'll stay all the way until we get to 0. And again, you can see this counts up to 12 because we're counting in seconds, and we're doing the other one 10 times a second. So it counts up to 12, but it can't get to 15 because you know, we don't have that simulated for that. So let's take a look at it going again. I'm going to count up one more time. And so we've gone through one cycle. And if we see, well, we've got 2 cycles in here now. So I'm not quite sure if this is working, and I kind of don't like it anyway, but let's just count down and see if it's going to, when it gets all the way down, if it's going to show that this increases its count, and it should. Not quite sure why it was off by a count, but I'm not quite sure that I like that circuit anyway. So let's go up, and what I'm going to do now is I'm going to look at my count, and I'm going to stop it by hitting the close down switch. So it stops, and now, well, my door should be ajar. So let's see, the door is ajar, but my light isn't blinking. So right here, I say it should blink if I have the system fault. What I really need is I need a second thing in parallel with that. So I need to insert a row afterwards, and this has to be my door ajar. So if either system fault or door ajar is high, then I'm going to blink my lamp. So that's C17. And I'm going to edit, line it up. And okay, so now we're going to download the program, give it another try. And it's not unusual. This is a fairly large program. I'm kind of losing track myself of everything we've got in here. So we're going to take a look at this, and I also want to pay attention to what this cycle counter is doing. So I have to reset this, and that'll put my counter at 0. Now, by the way, I'm also going, so I just pressed reset, and this counter did not reset to 0. My other counters that I have in here will reset. But let's just try this counter reset, and I'm going to have to press it for 5 seconds. So let's see. And it should change that to 0. When this hits 5, and it did. When that got to 5, this went back to 0. So the little reset mechanism that we have in here does seem to work. So let's quickly just go into our start mode. And, well, I have my switches all in the wrong position. But let me start going up. We have our green lamp. And we can take a look here. It's counting up. And then I'll just have it go down. And again, let's take a look at this counter thing. So it's at 0 now, and when we get all the way, it should count when we complete that cycle. Okay, so our yellow light went on, that went off. So, well, it's hard to say what's going on. Let's go up one more time and down one more time. Well, actually, when we're going down this time, what I'm going to do is I'm going to inject the fault, and it should stop. And we should take a look at that. Hopefully, we're going to see. Well, let's go down, and I'm going to. We still haven't retested our door ajar, so I'm going to. Let's see. Switch that. I'm going to go down, and now I'm going to stop it. And now our light is blinking. So now we can take a look at this, and now our door is ajar, and it's just stopped. Now I have to flip these switches back to their regular position. Now from this position, I can go either down or up. Now I am going to send it back down so we can just take a look at this cycle timer and see if, or counter, and see if that's doing its thing. Now again, we're starting from 52, so it'll not be as long until it gets there. So again, that counted when we went there. So that's pretty good. So one last thing, and maybe we'll take a look at visualization. We're going up, and now I'm going to inject the fault. And the fault, when I put that in, it's going to stop counting at 50. And this one will time out to 15 seconds, 3 seconds after it normally would. So my fault inject is here, the bottom switch. And now let's take a look at these circuits, because now we're counting down from 120 down to 0, but it's going to stop at 50. So I want to go down, and it is counting down. And when it gets to 50, this is still going to count. Normally, you know, here it's at 7, but it's going to count all the way past 15. When it gets past 15, we're going to say that's a door alarm. And then we'll get the blinking red light. And that works. Now, here we have a fault reset, and there's, you know, we don't have any switch for that. So how do we do that? Remember, we have this switch monitor in here. And what we, that's not what I was thinking of. We want the override loop. And I can go in here, and I can toggle C13. So I'm going into here, and I'm going to take a look at C13. And that is my fault reset. So right now, I'm going to activate this. So I'm going to turn it on, and as soon as I write this new value, what's going to happen, I hope, is that it's going to reset this, and the lamp will stop blinking, but then it'll, you know, restart itself after 15 seconds. So let's take a look. And as soon as I say yes, it should. Okay, so that let it go low. Now, what I need to do is, it's going to, if I turn it off again, and we have to pretend it's a toggle or a push button switch. So now it's activated again. So now again, it's stuck here at 50. So since it's stuck, it's going to come out again, and we're going to have another fault, and it's going to start blinking the red light. And that's what's going to happen when we go at that. So right now, I'm going to turn off or stop the system. And let's talk a little bit. Now we're going to go into the HMI after taking a look at this. And what we want to look at. And so one reason that, you know, when we're counting, when the door is going up, I'm saying that's 0 to 120. And when it gets to 120, I'm going to show that it's at the top. So I stop it at 50 when it's counting from 120 because I want to visualize this. And, you know, it's a little bit beyond halfway where this is. I'm going to pretend that this Jeep is in the way and the door can't shut. And so it's kind of arbitrary, but I kind of just said, maybe it should be around 50 is where we should stop it. So, next time out, and we're done with the PLC programming. So we're going to leave this as is. And, you know, if this counter shows us a little craziness, we might do something about it. But now what we want to do is we want to take a look at just visualization and what you can do there. We aren't going to get too deep into how to set up the buttons and whatnot. We had shown that in individual HMI films, but we're going to say, this is a project that we're creating just from an idea. And now that we've got a program and it seems to work, now how can we put together something so we can view it on our Wonderware HMI and make it come to life, so to speak. So that's what we're going to do next time out. So we'll see you then. Thanks.